A vector is a quantity having direction as well as magnitude, especially as determining the position of one point in space relative to another. In other words, vectors have a certain size or magnitude and direction. Vectors can be graphed on a Cartesian coordinate plane. The initial point can be plotted from the terminal point, and you can find the difference in distance between the 2 points as well as the direction. X naught can be referred to as the initial position, and X can be the terminal final position. X naught and X are both different vectors that can be added to find the resultant vector, the max magnitude and direction of X naught and X. This right here is the resultant vector, which is the max magnitude of the two X naught and X vectors. When we add vectors, we will add it in a heads or tail format. Vectors usually make the shape of a right triangle. Because many vector diagrams make the shape of a right triangle, we can use the Pythagorean theorem to get the max magnitude and direction between 2 points. The Pythagorean theorem is a squared plus b squared equals c squared, with c squared being the resultant vector. Velocity is defined as the speed of something in a given direction. Velocity is a vector because it tells how fast an object is moving and in what direction the object is moving. Velocity can be Formula for velocity is distance over time, or x divided by t, usually measured in meters per second. Number 1 says that Lucy rides a bike from her home. She goes north at 30 meters per second and east at 22 meters per second. What is her velocity relative to her mom waiting at home? In order to do this problem, we need to draw the compass rose. This is the compass rose. So this is north, south, east, and west. So first, the problem says that Lucy is going 30 meters per second north. So you would draw it in that direction towards north. Then it says she is going 22 meters per second east. So you would draw it in that direction. Since this is going in a heads to tail format, the resultant vector will be the hypotenuse of this. So it will go this way. So this line right here would be the resultant vector. All that's left is to find out the magnitude of this resultant vector. So we can use Pythagorean theorem. So rearrange c would equal the square root of a squared plus b squared. So we could say c can be defined as 30 squared plus 22 squared all over the square root sign, and this equals 37.2 meters per second. The second problem says that Sophie goes to the office. She goes 80 kilometers towards north. After 3 minutes, Sophie is 160 kilometers towards east. Find Sophie's average velocity. So we would start this problem the same way. We need to draw a compass rose. So this is north, east, south, and west. So it says that she goes north 80 kilometers and she goes east 160 kilometers. So this would be our resultant vector, which is the hypotenuse of the triangle. Now this problem is slightly different from other problems because this problem only gives you your information in kilometers, but you don't have time and you need velocity. So it does give you time. It says that she switches direction from north to east in 3 minutes. So 3 minutes is also equal to 180 seconds. And we needed it in seconds because meters per second is the standard form of writing velocity for most objects. So now we can do the Pythagorean theorem, which is c equals the square root of a squared plus b squared. So we can substitute that in as c equals 80 squared plus 160 squared. And then we can square root this entire thing. And our answer would be 178.88 kilometers. So this is the magnitude of the resultant vector. So now the only thing that's left to do is to find the velocity. So velocity is equal to x over t, or displacement divided by time. So we have our resultant vector, the magnitude is 178.88 kilometers. So we would divide this whole thing by 180 seconds because 3 minutes is equal to 180 seconds. And then our answer would be 1 kilometer per second.